Alright, welcome back. The topic of this video is risk and really how to identify where the high risk points are in the process of care. And we're going to look at a specific tool that allows us to do that. It's called Failure Mode and Effects Analysis, Fmea. That tool dates back to the 1940s, used by in the U.S. military and then also in NASA. It went on into manufacturing. It's being used in healthcare, and I think it's caught on because it's relatively simple to use. It's got its limitations, which you'll see, but it does provide a way for you to get like a view of the whole picture, everything that goes on, and what are the risk points. All right, so I'm going to go over that. Here we go. To understand this, let's look at this, the external beam radiotherapy workflow process. This was from some work that we published in 2009. If you look at this workflow process, you'll see that high-risk areas occur throughout the process. And the goal of Fmea is really to understand and identify these high-risk areas and prioritize them so that you know where to focus your safety improvement efforts. So the standard reference for this approach right now is APM Task Group 100, TG 100. It was a project that was 13 years in the making, and it's a very long report in the end, but a very definitive guide to how to look at this. And there are other things in TG 100 as well, but here we're focusing on Fmea. So let's take a step back and ask a fundamental question: what is risk? So you can think of it as this matrix, and you basically have severity of something and the occurrence of something, and they combine together to give you a risk index. So let's look at an example of what is a failure mode. It's basically anything that can go wrong in the process of care. Some examples: a miscommunication about coordinating chemotherapy with the start of radiotherapy. Number 2, radiotherapy delivered to a wrong location. And if you put these on the risk matrix, you can say maybe this wrong treatment location is quite severe for the patient, and occurrence is somewhere in the middle. It doesn't occur every day, sort of thing, which would put it over here, but it's also not every 100 years, sort of thing. So it's in the middle, and so that puts it in this red box. It's a high risk issue because it is severe and it occurs more frequently. The miscommunication about the start of chemotherapy, maybe the clinician decides this is sort of in the middle to low severity end, but then it occurs more frequently than the other one. So it puts it at a lower risk just because of the severity of it. Well, how do you do an Fmea? I'm going to do like kind of a dissection of this. So first you decide on a process to study. Typically you want to keep this small. You don't want to study like the entire radiotherapy workflow process because it could take a very long time to do that. But instead, if you narrowed it down and said, I want to look at everything that goes wrong in the simulation of patients who will receive SBRT treatment, that becomes a tractable problem. Then you assemble a team. One of the key things here is that you need people who are closely involved in the process, who know all the details of what's done on a day-to-day basis, and you need the right combination of people. And so typically this is a team of many different professionals. So in the example I just said, you'd have the simulation therapist, of course, you'd have the dosimetrist, having input in how these plans are set up. You'd probably have a physicist, you'd have an attending, and probably a nurse, each having their own perspective. So you draw a process map of what the steps of the workflow look like from A to Z. And I won't get into that, but it's just sort of a flow of procedures. And then you brainstorm on possible failure modes, looking at what can go wrong. And this is kind of a general brainstorming session to try to come up with everything and not try to filter it in any way. After that's done, you collect these failure modes and you score them through a system that I'll show you in a minute. and basically scoring them on this risk dimension, so severity, occurrence. This isn't quite it because there's another dimension here that I didn't mention. That's the detectability dimension. So if something does occur, will it be detectable before it reaches the patient? And if it has a good detectability score, overall the risk may be low because you will find it and address it. So these three scores are what go into the Fmea. So you combine them together, and the system, the methodology here is that you just multiply them, and you get a risk priority number, RPN. And that's just the severity score times the occurrence times the detectability. What do these scores look like? Here are the tables from TG100. You can see the occurrence score going from 0 to 10, the severity score going from 0 to 10, and the detectability score going from 0 to 10. One thing to note is that the detectability you have to think about this, so the score of 10 means that something is relatively undetectable. It's hard to detect. It gives you a high score. Detectability of 1 means it's easy to detect. So you multiply these three numbers together, and then you get a ranked, you have a number for each failure mode, and that allows you to rank them in order of importance. Here's an example. Miscommunication about a repeat treatment case that had an RPN of 294 in this study because the severity was relatively high, the detectability was relatively high, it was relatively hard to find. A wrong treatment location due to human error identifying the location in the imaging system. Again, pretty severe because of a potential mistreatment. Occurs relatively often, but it's very detectable, score of 2. So the overall risk score is lower. So after doing an exercise like this, then you might focus first on the first failure mode because that's the one that has a higher risk score, and try to address that one. One word about Fmea versus what we've learned already about incident learning. So in incident learning, in a sense, you're investigating what happens after an incident or near miss occurs versus anticipating what will happen before an incident occurs. That's more like what we're talking about with Fmea. These two are complementary. So the root cause analysis in incident learning versus the risk analysis. And you can see that here in this study that was done looking at all events that can happen in the blue on the left through an Fmea process versus all the events that were identified through incident learning over a period of several years. There were 33 events. So there were different data sets, and in the study you could see that they did overlap. Here's the overlap shown. So there were, in other words, there were some events that were seen in both systems, but some that were only seen either in the Fmea or only in the incident learning. You could see that actually 41% of the issues that you found in Fmea in this study were not observed in incident learning. And that's really a function of the fact that there are these sort of rare events, issues that don't often come up in clinical practice, but things that you can imagine happening that you can capture with a prospective risk analysis that you just don't see by running your incident learning system. So the conclusion of this is that these two approaches, risk analysis is a complement to incident learning, and they kind of help each other out. All right, so those are the basics of risk through the lens of Fmea. A key reference for this is AAPM Task Group 100. Many years in the making, a very definitive and valuable document and guide around this. And it talks not only about Fmea, but other things like a process called FTA, fault tree analysis, where you can look at errors propagate through the process of care. It talks about quality management standards and other things. So a really valuable resource. And there are some other reading as well that I will leave here for you to dig into. And in general, the topic of safety and quality in radiotherapy and healthcare in general is very vast and the more you understand, the less you know. And that can be said of probably all of physics, but yeah, I hope you've learned enough to know that that there's a lot more to learn. Let me put it that way. Okay, thank you.